Hi guys, this is Dr. MK and welcome to Ultimate Organic Chemistry. This video is mainly for class 11, class 12 and BSc chemistry studying students, and also it will be very much useful to NEET, IIT JEE and PG TRB studying candidates also, because I am going to discuss one of the fundamental reactions of organic chemistry, that is benzene diazonium chloride and its reactions. I am not going to discuss the mechanism in detail. I am going to use only shortcut to arrive at the products. So do watch the video without skipping. And at the end of the video, I am going to discuss one of the important questions from NTA mock test for NEET. Okay, shall we start? Okay, first let us discuss the preparation of benzene diazonium chloride salt. You need to take aniline and you treat with sodium nitrite . Along with that, you need to use HCl at 0 degree centigrade. If you are not given this one, you can expect this one, that is HNO2, that is nitrous acid at 0 degree centigrade. It will lead to the formation of benzene diazonium chloride salt. Okay. You have taken HCl as acid, so the counter anion, that is Cl minus, has come here. Suppose if you take H2SO4 as an acid, the counter anion HSO4 minus will be given here. Okay, so this is about the difference. Okay, I have generally given benzene diazonium salt. Okay, here the exact name is benzene diazonium chloride. Okay, so now let us discuss briefly how it forms. This is a shortcut only, this is not the exact mechanism, right? So now aniline is reacting with nitrous acid. So nitrous acid is given as HNO2. It can be written like this, that is nitrogen is connected to oxygen by a double bond and another oxygen by a single bond. Okay, so basically what happens, removal of water is taking place. So after removal, you will get a compound known as Diazo hydroxide. So once it is formed, it can react with HCl. We know that HCl will be, will separate as H plus and Cl minus because it is an acid. So this acid needs an anionic counterpart, that is OH minus. So this nitrogen lone pair pushes its electron towards the nitrogen atom. As a result, the OH is leaving as OH minus, and H plus and OH minus, they are reacting together. It will be leaving as water to form this compound. Okay, that is benzene diazonium chloride. Okay, since nitrogen has donated its pair of electron, it has generated a positive charge, and this Cl minus will be remaining here, because whenever you have a cation, you will be having another anion also. Okay, right, this is about the mechanism for the preparation. This is a shortcut mechanism, this is not a perfect mechanism. Okay, right, let us discuss the reaction of benzene diazonium chloride. Okay, this is about plenty of reactions are there. First of all, you need to know one thing, whatever the reagent is given, you just check the anion part of the reagent. Okay, just that anion part will be attacking this benzene ring, right? So let me give a brief thing, that is, if you have diazonium chloride like this, you are treating with a reagent called MX. So which will be, M is considered to be a metal, so it will be separating as M plus X minus. This X minus attacks here and this will be leaving, right? So you will get benzene, along with you have a functional group called X. Okay, so this nitrogen is leaving as N2 and this M plus the Cl minus will be leaving as MCl. So this is a basic mechanism. This is about the entire process. Whatever the reagent is given, most of the cases you can guess the product by very easy thing also. Okay, so that is what I am going to discuss here, right? So now the thing is benzene diazonium salt into halobenzene, that is what we are going to discuss. That means halobenzene means it can be chlorobenzene, bromobenzene, iodobenzene or fluorobenzene, etc. Okay, so right, so let us discuss the first reaction. When benzene diazonium chloride is treated with CuCl, that is copper 1 chloride, you can see that the counter anion will be Cl minus, so it will be attacking here and this will be leaving us to form chlorobenzene as a product. So this is a basic mechanism, right? So if you are given CuBr, that is copper 1 bromide, that means Cu plus Br minus, this Br minus will be attacking here and it will be leading to the formation of bromobenzene, right? Along with that you will get the nitrogen gas. So these two reactions are called as Sandmeyer reaction. Okay, so what are the other method to prepare this chloro and bromobenzene? Yes, there is another method which is known as copper metal along with that HCl. Okay, here also you can find that anion part is Cl minus, so that will attack here and this will be leaving and it will lead to the formation of chlorobenzene and the nitrogen gas. Okay, so the next method is copper along with that HBr, it will lead to the formation of bromobenzene, right? So these two processes are called Gattermann reaction. Okay, so this is about chloro and bromobenzene preparation methods. So through this process you cannot prepare iodo and fluorobenzene. So there are two other different processes for preparing these two compounds. Okay, for example, if you want to make iodobenzene, you need to treat this benzene diazonium chloride with Ki, that is potassium iodide. So this will be separating as K plus I minus. So this I minus will attack here and this will be leaving and you will get iodobenzene along with that nitrogen, and this K plus and Cl minus will be leaving as potassium chloride, right? So finally we will discuss the formation of fluorobenzene, right? So for this purpose you need to treat with a reagent known as this is called fluoroboric acid. Okay, so if you are not given, you can use NaBF4 also. Okay, this is said to be sodium tetrafluoroborate. Okay, so when you treat this any one of this reagent with benzene diazonium chloride, initially what will happen? It will separate as H plus BF4 minus. Okay, so first thing is it will undergo ion exchange. So this anion will be exchanging, it will form this type of diazonium salt, right? When you heat this diazonium salt, so the counterpart will be F minus. So this can be written as BF4, can be written as, this will be like this. So it is a perfect tetrahedral. So this anion will attack here, this will be leaving, right? So what happens, this BF4 minus will be converted into BF3 and when it attacks here, it will leave as N2 nitrogen and this diazonium salt will be converted into fluorobenzene. Okay, so along with that, if you use NaBF4 you will get NaCl, if you use HBF4 you will get HCl. That is a final product. Okay, so this reaction is very important in terms of NEET as well as JEE. This reaction is known as Balz-Schiemann reaction. Okay, so far we have discussed the preparation of halobenzene from diazonium salts. Okay, so now let us discuss other functional groups from diazonium chloride salts also. Okay, so that is benzene diazonium salt into other substituted benzene, right? So when I treat with CuCN, that is copper cyanide, in the presence of KCN, so the counterpart will be Cn minus, so it will be replacing this N2 and you will get this is benzonitrile. Okay, please remember, right? Suppose if you use sodium nitrite with copper and in the presence of heat, otherwise you can use that nitrous acid along with that copper oxide. So what will happen? This will be separating as Na plus NO2 minus. This will be separating as H plus NO2 minus. So the counter anion will be attacking here, and you will get, this is nitrobenzene, along with that you will get nitrogen gas. So this is another method, right? So we will have another method, that is this compound is known as hypophosphorus acid. When you treat hypophosphorus acid with benzene diazonium chloride, it will lead to the formation of benzene. So you may wonder how this hydrogen is there, how it should be a cation only, how it goes as anion. I said so far that anion part only will attack that diazonium nitrogen atom, this nitrogen containing carbon atom, only anion part will be attacking. How this is taking place, that is a question you may have. So I explained the briefly mechanism of this process. Hypophosphorus acid is a very good reducing agent. So during the course of the reaction, this electron pushes towards the phosphorus atom. This H minus will attack here. Okay, so this part will be leaving. So hydrogen will be added here. So which can be written, or if not written also no problem, because this is benzene system only. Okay, so what happens to this part? Just check. So phosphorus double bond OH, and here you have hydrogen atom, right? So you are using water as a reagent. So water, what will happen? It will attack here. This electron will be moving towards oxygen atom, and it will form phosphorus double bond O, and here you have single bond OH. Here you have OH from water molecule, and here you have hydrogen. During the process, H plus will be leaving, that will be from water. Okay, so this H3PO2 will be converted into H3PO3, that is phosphorus acid will be formed, right? So please remember, this is one of the most important reactions. Okay, so many times the questions from this reaction were asked in JEE examination. Please do remember, right? So if you do not have a hypophosphorus acid, what is the other pathway you can ask? Yes, there is another pathway, that is when you use ethanol as a reagent. This benzene diazonium chloride will be converted into benzene. Okay, so how this reaction is taking place, that I am going to explain. Okay, just listen. So CH3, you can write like this. CH3, you have oxygen, hydrogen and hydrogen, that is ethanol. So during the course of the reaction, this electron comes towards oxygen atom, and this hydrogen will be leaving as H minus and attacks here, right? So this part will be becoming CH3, C double bond O hydrogen, that will be converted into acetaldehyde. It is getting oxidized. Okay, so this hydrogen will be leaving as H plus. This H plus and Cl minus will be forming HCl, and nitrogen gas will be removed, and the formation of acetaldehyde will be taking place to form benzene as a product. Okay, this is also one of the important reactions. Please remember. So benzene diazonium chloride to benzene can be converted by two pathways. The first one is the treatment with hypophosphorus acid. The second one is with ethanol as a reagent. Right. Okay, we have another example where you can treat water and dilute sulfuric acid or water. If you heat it, and it will lead to the formation of phenol. Okay, so instead of water, you can also get the another option, that is copper oxide along with water. This also will form phenol. Okay, we know that water will split as H plus and OH minus. So the negative part will attack here, and it will lead to the formation of phenol as a product. Okay, this is one of the important reactions also. Okay, so we have another example that when benzene diazonium chloride is treated with H2S as a reagent, or potassium ethyl xanthate in the presence of alcoholic KOH, it will lead to the formation of thiophenol. So how this reaction is taking place? So what is happening here? So this H2S can split into H plus and with SH minus. So this HS minus will be attacking here, and it will lead to the formation of thiophenol. So what do you mean by potassium ethyl xanthate? This is a new reagent. Some people might have studied, some people may not have studied this. So this is a well known sulfur based reagent. Okay, so this is known as potassium ethyl xanthate, okay, which is a very good sulfur atom donor, please remember. So these are the other reagents that one can do with benzene diazonium chloride, and from that benzene diazonium chloride you can prepare various kind of substituted benzene products. Okay, we have another example, that is benzene diazonium salt coupling reaction. So far we have discussed displacement type of reaction, and we are going to discuss here that is coupling reaction. So what do you mean by coupling reaction? When benzene diazonium chloride is treated with phenol in the presence of basic medium, that is sodium hydroxide, you can take, it will lead to the formation of this product, that is para hydroxy azobenzene, which is orange in color. Okay, so how this reaction is taking place, I will give you a brief thing. So I already said that benzene diazonium chloride can be written like this also. You have Cl minus, and when phenol is reacting here, okay, so when this electron is coming, this is coming here, and it will attack directly the nitrogen atom, and this electron will push towards the nitrogen positive. So it will lead to the formation of N double bond, because a triple bond after reaction it becomes double bond, and there will be carbon nitrogen single bond is formed between here. Okay, so this is about the basic mechanism, and this reaction will be taking place in the presence of base medium, because this hydrogen whatever is leaving will be abstracted by that the sodium hydroxide. Okay, so instead of phenol you can also use aniline as a reagent. When you use aniline, the same type of reaction will take place. It will lead to the formation of para amino azobenzene, which is yellow in color, right? Same process is taking place. Instead of here phenol, OH, instead of OH you have NS2 here, and the same type of mechanism will be taking place, right? So we have another example, that is, this is known as beta naphthol or 2-naphthol. If you have not, if you are not aware of this numbering of this naphthalene system, I have already given in the IUPAC nomenclature. I will give the link in the description section. Just go watch. Okay, right. So when beta naphthol is reacting with benzene diazonium salt, this first position, this is said to be first position. This will be more reactive in nature, right? Because this lone pair will be pushing towards this carbon atom, and this electron will attack here. And it will attack here, and it will lead to the formation of the azo-dye, right? So how this is forming, the same concept only. Right, so here you have this electron will attack here, and it will shift towards this nitrogen atom, and the color of this azo-dye will be scarlet red dye. Please remember, this question was asked in 2015 IIT JEE Advanced Entrance Examination. Please remember, you can check the question also. I believe so. This is the same examination that I am talking about. Okay, right. So this all three compounds are called as azo compounds. This reaction should be carried out in the presence of sodium hydroxide. These azo compounds are bright in color. They are used as a dye. Okay, please remember the application of this azo compound also. Right. The final example what we have is when you treat this diazonium chloride in the presence of sodium hydroxide and benzene as a reagent. So this reaction is little bit tricky. It will undergo via a free radical pathway. So just remember that this hydrogen will be replaced, and it will directly attack with this benzene atom. It will lead to the formation of a compound known as biphenyl. Okay, so this reaction undergoes via a free radical pathway. I am not going to discuss the mechanism in detail here, right? Just remember, right? So this reaction is known as Gomerg-Bachmann reaction. So this is one of the important naming reactions. Okay. So in this video we have discussed so many naming reactions, that is Sandmeyer, Gattermann and Balz-Schiemann, and you can have Gomberg-Bachmann reaction and azo coupling also. So many reactions that we have discussed. So this concept is very much important, right? Now let us go to the final topic, that is NTA mock test question. So they have given a question like this: consider the following diazonium ions, the order of reactivity towards diazo coupling with phenol in dilute NaOH solution. Okay, you have given 4 compounds and you need to find out the reactivity order with phenol. This was a question asked in that recent NTA that NEET entrance exam mock test. Okay, right. So before explaining this, I would like to give the basic thing, that is when this diazonium salt is connected to an electron withdrawing group, when it reacts with phenol, what will happen? This is the first case. So we have the second case, that when benzene diazonium chloride is reacting with electron donating group containing system, and this system is reacting with phenol, what will happen? This is the second case. This is the first case and this one is second case, right? So we know that this electron withdrawing group means it will pull the electron. I am not explaining with the resonance structure because it will take so much time. I am just giving a brief idea. So when this electron is pulling the electron, means this electron will move towards this withdrawing group, and this electron will move towards withdrawing group, and this electron will move towards this withdrawing. So total system will be moving towards this electron withdrawing group. As a result, here the positive charge will be increased because electron density is decreased. Okay, because this is drawing this electron from here to here, right? So here positive charge density will be increasing. So already the nitrogen is having positive charge. Because of this electron withdrawing group, still the positive charge density will be maximum. Okay, so immediately it will quickly react with the phenol and it will shift towards this nitrogen atom. Okay, so this will be more reactive, you can say. Whereas if you happen to see this case, this is electron donating group, what will happen? It will give the electron towards the nitrogen atom. Okay, so nitrogen is somewhat stabilized because already some donor is there. When it is ready to give electron, so it will not ready to react that easily. Okay, so when electron withdrawing group is there, means it will react faster. When donating group is there, the reactivity will be slower. Okay, this is less reactive. So this is the thing you must know. Okay, so now let us discuss the nature of the functional group. Here you have nitrogen lone pair, so it is considered to be electron donating group, and here you have NO2 where the nitrogen will be having positive charge, it needs more electron, it is considered to be electron withdrawing group, and here the methoxy group oxygen will be having lone pairs, and this will be electron donating group, and methyl most of you know that this is also electron donating group where inductive effect will be taking place. Here you have resonance effect. So if you want to know more about this topic, you please mention in the comment section. I will put a separate video on what is inductive, what is resonance, what are the groups are said to be plus I plus R or minus I minus R, that I will discuss, okay, based on your need only, right? So this is said to be minus R group, okay, because electron withdrawing means you need to give minus, electron donating means you need to put the sign plus, please remember. Okay, so this is electron withdrawing group and this should be the most reactive, right? So remaining all are electron donating group. So you need to find out which is stronger one, which is weaker one, that is stronger with donating group, weaker donating group, okay. So here you have lone pair, it can easily give electrons by resonance effect, but here you cannot give that much easily because carbon does not have any lone pair of electron, okay. So this is weak electron donating group, these two are stronger, okay. So compared to these three, this is weaker, so it will be more reactive than the rest of the two, okay. So this is most reactive. The next one is fourth diazo compound. Another one is you have nitrogen here, here you have oxygen here. So both are having lone pair of electron. The lone pair will be same, but which will be a better donor? So you need to know the electronegativity. For example, the electronegativity order goes like this. The most electronegative atom will be oxygen, and then you have nitrogen. Okay, when you compare these two things means, okay. So oxygen is more electronegative. This is less electronegative in comparison. So more electronegative means it cannot give the electron that easily. Okay, so this can be more reactive, whereas in this case this is very less electronegative. It will quickly give the electron towards N2 plus. So what will happen? Immediately the electron will move. It will move towards the nitrogen atom, and it is stabilized. That means it will be least reactive when compared to the rest of the three compounds. So the reactivity order goes like this. So least reactivity 1, and then 3, then 4, and then finally 2. That's all about the topic. Okay. So guys, hope you understood the concept discussed in this video. I believe it will be very much useful to you, because definitely 1 or 2 questions will be asked in NEET or JEE examination from this topic. If you find the video is very much useful to you, just give a like, share with your friends, and please do not forget to subscribe Ultimate Organic Chemistry channel. I will meet you all people with an interesting topic. Until then, take care. Bye.